Welcome students in growth project 2021-22, which is conducted by Restriction Samstha Satara and managed by Yashwantrao Chavan Institute of Science, Satara. In previous lecture, we have studied the nature of conic is ellipse. Ellipse या conic संदर्भात आपण पाठीमागच्या लेक्चर मध्ये डिस्कस केलेला आहे. त्याच्यामध्ये त्याचे इक्वेशन्स, parametric equation, tangent to an ellipse and condition for tangency या गोष्टी आपण पाठीमागच्या लेक्चर मध्ये बघितलेल्या आहेत. आता पुढील लेक्चर मध्ये आपण हायपरबोला या कोनिक संदर्भात माहिती घेऊयात किंवा अभ्यास करूयात. Now, what is hyperbola? What is the nature of the hyperbola? This is the nature of the hyperbola. Now, the definition of hyperbola is, an hyperbola is the locus of a point which moves in a such a way that its distance from a fixed point bears a constant ratio to its distance from a fixed line. The fixed point is called the focus and fixed line is called the directrix. And the constant ratio is called the eccentricity of the hyperbola. And it is denoted by E. पहिल्या लेक्चर मध्ये आपण बघितलेलं आहे की the nature of conic is depends upon the constant ratio E. तर त्या constant ratio मध्ये एखाद्या पॉइंटचं फिक्स्ड पॉइंट पासूनचं डिस्टन्स आणि फिक्स्ड लाईन पासूनचं डिस्टन्स हे कॉन्स्टंट रेशिओ येतो. त्या फिक्स्ड पॉइंटला फोकस म्हणतो आपण आणि फिक्स्ड लाईनला डायरेक्ट्रिक्स म्हणतो. तर तो कॉन्स्टंट रेशिओ आपण ई ने दाखवतो. तो जर ग्रेटर दॅन 1 असेल तर ते नेचर ऑफ कोनिक हायपरबोला असतं. ठीक आहे. नाउ दिस इज द नेचर ऑफ द हायपरबोला. द इक्वेशन ऑफ हायपरबोला इज गिवन बाय x square upon a square minus y square upon b square is equal to 1. And consider x-axis, y-axis, O is the origin. This is the nature of hyperbola. A dash are the vertices of the hyperbola. S, H dash be the foci of the hyperbola, which is a fixed point. Let D is equal to x is equal to A upon E and D dash is x is equal to minus A upon E are the directresses of the hyperbola. P be any point of the hyperbola. Then the distance SP upon PM is constant ratio E, which is greater than 1. Then S is called focus and B is called directrix. Now, conjugate hyperbola. याच्यामध्ये दोन टाइप आहेत हायपरबोलाचे. जसं इलिप्स मध्ये आपण हॉरिझॉन्टल आणि व्हर्टिकल इलिप्स पाहिला तसं या ठिकाणी आपण स्टँडर्ड हायपरबोला आणि त्याचा कॉन्जुगेट हायपरबोला. त्याचं इक्वेशन आहे y square upon b square minus x square upon a square is equal to 1. याचं नेचर हे समोर दिलेल्या फिगर करून असेल. याच्यावर let S dash be the foci of the hyperbola. D and D dash are the directresses. Equations are given with names. P be any point, then distance of point P from the focus and from the directrix is constant ratio SP upon PM is E, which is greater than 1. Then this is called conjugate hyperbola. Now, vertices of the hyperbola. The equation of the hyperbola is x square upon a square minus y square upon b square is 1. Then the hyperbola intersects x-axis at a dash and it does not intersect to y-axis. Then consider this hyperbola which intersect at x-axis at a0 and a dash minus a0. Then the points A and A dash are called vertices of the hyperbola. Here A and A dash are vertices of the hyperbola. Now next point is principal axis of the hyperbola. Now the axis That means the lines where the conic is symmetric. Now here for hyperbola, transverse axis, a line segment through a foci of the hyperbola is called transverse axis, and conjugate axis is a line segment through a center and a perpendicular to the transverse axis is called the conjugate axis. हायपरबोलासाठी दोन ऍक्सिस आहेत, त्यातील एक म्हणजे ट्रान्सव्हर्स ऍक्सिस आणि दुसरा कॉन्जुगेट ऍक्सिस. ट्रान्सव्हर्स ऍक्सिस हा लाईन फोकाय मधून पास होतो आणि कॉन्जुगेट ऍक्सिस हा सेंटर मधून पास होतो आणि तो ट्रान्सव्हर्स ऍक्सिसला परपेंडिक्युलर असेल. The transverse axis and conjugate axis together are called principal axis of the hyperbola. Now see, this is a hyperbola with center at O, vertices A dash, foci S dash, directrix D dash. Then the axis x-axis is the called transverse axis, and y-axis, this is the conjugate axis, which is passes through the center and perpendicular to the transverse axis. The transverse axis passes through the foci. Now, distance between foci of the hyperbola. Consider a hyperbola with center O, vertices A dash, foci S dash, directrix D dash. Then the distance between foci is S dash. The foci, the coordinates of the foci are SA is 0 and S dash minus A 0. Then the sum of S dash is the distance between two foci. Then this distance is 2AE. Therefore, the distance between foci is 2AE. Now, distance between directrices of the hyperbola. Consider a hyperbola with foci S dash and directrix D is equal to D, x is equal to A upon E, and D dash x is equal to minus A upon E. Then Z dash is the distance between the directrices, and this is 2A upon E. Therefore, the distance between the directrices is 2A upon E. Now let us see end coordinates of the lattice rectum of the hyperbola. Endpoints of the lattice rectum काय आहेत ते आपण पाहूया. याच्यामध्ये this is hyperbola with foci and directrices. Then the lattice rectum is the chord perpendicular to the axis and passing through the foci. Here L dash is the lattice rectum. This is our lattice rectum. Then the equation of the hyperbola is x square upon a square minus y square upon b square is 1. Then SL and SL dash be the semi-lattice rectum of the hyperbola. Here SL and SL dash be the semi-lattice rectum. Then L is equal to AE L. Here consider this distance be L. Then this point is on the hyperbola. Therefore, the equation of hyperbola is satisfied by L. By calculating, we get L square is equal to L square upon B square is equal to 1. That is L square is equal to B square into bracket E square minus 1. Therefore, L square is B square into B square upon A square by the relation between A, E and B. Now, therefore, L square is equal to B raised to 4 divided by A square, and L is equal to plus or minus B square upon A. म्हणजेच L ची व्हॅल्यू प्लस और मायनस B square upon A आली. Therefore, the endpoints of the lattice rectum L is AE B square upon A, and L dash AE minus B square upon A. Therefore, these are the endpoints of the lattice rectum. Endpoints of the lattice rectum are this L, L dash, AE and B square upon A. L dash is AE minus B square upon A. Now, length of the lattice rectum. What is the lattice rectum? Lattice rectum is the focal chord which is perpendicular to the axis. Consider a hyperbola with foci and directresses DD dash, SS dash and DD dash. Then the LL dash be the lattice rectum whose end coordinates are AE plus or minus B square upon A. Then this length of lattice rectum is equation of hyperbola is given by x square upon a square plus y square upon b square is equal to 1. Sorry, इथं minus पाहिजे plus झालेला आहे. x square upon a square minus y square upon b square is equal to 1. Therefore, SL and SL dash with the semi-lattice rectum. Therefore, the endpoints of the lattice rectum are LL dash. Then the length of the lattice rectum is sum of LS and SL dash, that is 2b square upon A. Therefore, length of the lattice rectum is 2b square upon A. Now, in tabular form, we will see that the standard form of the hyperbola, standard equation of the hyperbola, and there are some terms which are useful for the study of the hyperbola. The equation of hyperbola is x square upon a square minus y square upon b square is 1, and conjugate hyperbola is y square upon b square minus x square upon a square is 1. Therefore, vertices are A0, A dash minus A0, B 0B and B dash 0 minus B. Length of the transverse axis is 2A and 2B. Length of the conjugate axis is 2B and 2A. Then relation between A, B and E is B square is A square into E square minus 1 and A square is equal to B square E square minus 1. Foci are S, AE0 and S dash minus AE0. For the conjugate hyperbola, 0, BE and S dash minus BE. Distance between foci is 2AE and for conjugate hyperbola 2BE. Equation of the directress is x is equal to A upon E and x is equal to minus A upon E. And for the conjugate hyperbola, y is equal to B upon E and y is equal to minus B upon E. The distance between directresses is 2A upon E for standard hyperbola and for conjugate hyperbola 2B upon E. That is, next term is endpoints of the lattice rectum. For standard hyperbola, LAE B square upon A and L dash AE minus B square upon A are the endpoints of the lattice rectum. And for the conjugate hyperbola, L A square upon B BE and L dash A square upon B minus BE are the endpoints of the lattice rectum. And length of the lattice rectum is 2B square upon A and 2A square upon B. Now, parametric form of the hyperbola is x is equal to A sec theta and y is equal to B tan theta for the standard hyperbola, and for conjugate hyperbola x is equal to A tan theta and y is equal to B sec theta. Now, take one example for the hyperbola. Find length of the principal axis, eccentricity, coordinates of the foci, equation of directresses, and length of the lattice rectum of the hyperbola x square upon 25 minus y square upon 16 is equal to 1. The solution is given equation of the hyperbola is x square upon 25 minus y square upon 16 is equal to 1. Therefore, compare this with standard equation a square is 25 and b square is 16. Therefore, A is 5 and B is 4. Therefore, length of transverse axis is 2A, that is 10, and length of conjugate axis is 2B, that is 8. Therefore, we have relation between A, B, and E is B square is A square into A square minus 1. Therefore, we get E square 16 upon 25 is E square minus 1. That is, E square is 1 plus 16 upon 25. That is 41 upon 25. Therefore, E is equal to square root 41 upon 5. The coordinates of the foci are S, A is 0 and S dash minus A is 0. Now, we have the value of E, that is eccentricity, as root 41 upon 5. Therefore, the coordinates of the foci are S is root 41 0 and S dash is minus root 41 0. Now, equation of directress is y is x is equal to the x पाहिजे चुकून y झालेला आहे x is equal to my plus or minus a upon e, that is plus or minus 25 upon root 41, and length of the lattice rectum is 2a square upon b, that is 25 upon 2. Now, next question is same as above, but equation is changes by sign only. X square upon 25 minus y square upon 16 is equal to 1. For this hyperbola, we have to find the sum terms. Now, given equation is this. This can be written as y square upon 16 minus x square upon 25 is equal to 1, which is conjugate hyperbola. And for conjugate hyperbola, the equation is y square upon b square minus x square upon a square is 1. Therefore, b square is 16 and a square is 25. B is 4, A is 5. Then length of transverse axis is 2B is 8. Length of conjugate axis is 2A, that is 10. We have relation between A, B, and E. We use this for finding eccentricity. We know A square is B square, E square minus 1. Putting the values of A and B, we get E square is equal to 1 plus 25 upon 16, that is 41 upon 16. That is, E is equal to root 41 upon 4. Then the coordinates of the foci are, this is for conjugate hyperbola, S is 0B and S dash is 0 minus BE. S is 0 root 41 and S dash is 0 minus root 41. The equation of directress is x is equal to plus or minus b upon a. Therefore, plus or minus 16 upon root 41. Here we have to take y. Then length of the lattice rectum is 2a square upon b, that is 25 upon 2. Now, consider the hyperbola with foci SS dash, directress D dash. Let P be any point on the hyperbola. Then the focal distance SP and PS dash or S dash P are the focal distance. Then this difference of focal distance of a point on the hyperbola is the length of transverse axis, which is constant. या दोन फोकल डिस्टन्स मधला डिफरन्स हा ट्रान्सवर्स ऍक्सिस येतो. तर SP and S-P are focal distance of the hyperbola. We know the focal distance property SP is equal to EPM. Therefore, and S-P is equal to EPM dash. Therefore, difference between S-P and SP is S-P minus SP is E into M dash. PM dash and PM dash, that is M dash. PM dash and PM चा difference M dash येतो. Therefore, S-P minus SP dash is E into distance between directresses. M dash is the distance between directions, and this is 2a upon e. Therefore, the difference between focal distance of a point of the hyperbola is 2a, and which is the length of the transverse axis. Now, auxiliary circle of the hyperbola. What is the auxiliary circle of the hyperbola? A circle drawn with the transverse axis AA dash as a diameter is called an auxiliary circle of the hyperbola. Consider this hyperbola. तर ऑक्झिलरी हायपरबोला म्हणजे काय, तर याचा ट्रान्सव्हर्स ऍक्सिस हा ए डॅश हा जो ट्रान्सव्हर्स ऍक्सिस आहे तो ज्या सर्कलचा डायमीटर असेल ते सर्कल म्हणजे ऑक्झिलरी सर्कल ऑफ दी हायपरबोला. नाउ S dash are the foci, D dash are the directresses, A dash are the vertices. Then A dash is the diameter of this circle. Therefore, this is auxiliary circle. Take example. Find the equation of the hyperbola. Refer to its principal axis, whose distance between foci is 10 and centricity is 5/2. आपल्याला इसेंट्रिसिटी आणि डिस्टन्स बिटवीन फोकाय दिलेले तर आपल्याला हायपरबोलाचे इक्वेशन फाइंड आउट करायचे. इच व्हॅल्यू 5/2 आणि डिस्टन्स हा 10 दिलेले. दॅट इज 2a इज इक्वल टू 10. a ची व्हॅल्यू 5/2 आहे, ती पुट केली की आपल्याला a ची व्हॅल्यू मिळेल 2. a ची व्हॅल्यू 2 असेल तर आपल्याला a² इज इक्वल टू 4 मिळेल. Then relation between a, b and e is b² is a² into bracket e² minus 1. That is b² is given by 4 into 25/4 minus 1. That is b² is equal to 21. a² ची value 4, b² ची value 21. Therefore, we have the equation x² upon 4 minus y² upon 21 is equal to 1. This is the required equation of the hyperbola. Now, next question is find the equation of the hyperbola whose distance between foci is 10 and the length of conjugate axis is 6. We have given conjugate axis 2b is 6 and distance between foci is 10. That is 2ae is 10. Therefore, 2b is equal to 6. म्हणजे b is equal to 3 मिळाला आपल्याला. Therefore, b² is equal to आपल्याला रिलेशन माहिती आहे a² e² minus 1. याच्यावरून आपल्याला a ची व्हॅल्यू 5 मिळेल आणि b² ची व्हॅल्यू आपल्याकडे आहे b ची व्हॅल्यू 3. Therefore, b² is 9 आणि a ची व्हॅल्यू मिळालेली आहे 5. याच्यावरून आपल्याला a² ची व्हॅल्यू मिळेल a² is 16. Therefore, the required equation of the hyperbola is x² upon a² minus y² upon b² is 1. That is x² upon 16 minus y² upon 9 is 1. Now, asymptote. What is asymptote? Consider the line x upon a is equal to plus or minus y upon b. They passes through the origin. याच्या दोन लाईन आहेत त्या ओरिजिन मधून पास होत असतील तर कन्सिडर द पॉइंट P moves along the line so that distance OP goes on increasing. Then the distance between P and hyperbola goes on decreasing but does not become 0. Here the distance between the point and the hyperbola is tending to 0. Such a straight line is called an asymptote for the hyperbola. These two lines are asymptote of the hyperbola. Now, consider the hyperbola with vertices a dash, foci s dash, directresses d dash. Then PB any point on the hyperbola. Then SP upon PM is constant ratio. Then the focal distance SP and S dash P are the focal distances. Then the difference between the focal distances of the point to the hyperbola is the length of the transverse axis which is constant. हे आपण मगाशी प्रूव्ह केलेला आहे. तर ह्या डिफरन्स हा आपल्याला मिळतो 2a. Distance between focal distance of the point of the hyperbola is length of the transverse axis. That is the length of the major axis, that is transverse axis. Now tangent to hyperbola. Tangent to the hyperbola is a straight line which intersects the curve hyperbola into two coincident points is called the tangent of the hyperbola. Consider the hyperbola with foci SS dash and directresses DD dash. Then this line is the tangent of the hyperbola. अशी लाइन की त्या hyperbola एका पॉइंट मध्ये intersect होते. Now the equation of the hyperbola at a point is x1 y1 is x1 divided by a square minus y1 divided by b square is equal to 1. This is by replacing x square by x1 and y square by y1. Therefore, this is the equation of a tangent at a point px1 y1. And now condition for tangency. दिलेली लाइन ही दिलेल्या हायपरबोलाची टॅन्जंट आहे का नाही हे चेक करण्यासाठी आपण कंडिशन फॉर टॅन्जन्सी बघणार आहोत. त्याच्यासाठी कन्सिडर अ लाइन y is equal to mx plus c and equation of hyperbola is x square upon a square minus y square upon b square is 1. then आपल्याला पाहिजे y is equal to mx plus c ही लाइन हायपरबोलाची टॅन्जंट आहे का नाही. त्यासाठी equation of line is y is equal to mx plus c. It can be written as mx minus y plus c is equal to 0. This is equation 1. And equation of tangent of hyperbola at a point x1 y1 is x1 upon a square minus y1 upon b square is equal to 1. And this can be written as in this form, which is equation 2. x1 upon a square into x minus y1 upon b square into y minus 1. From 1 and 2, both are the equation of the tangent to the hyperbola. Therefore, comparing the coefficient of like terms, we get x1 upon a square upon m is equal to minus y1 upon b square divided by minus 1 is equal to minus 1 upon c. That is, we get x1 is equal to minus a square m upon c and y1 is minus b square upon c. But the point px1 y1 lies on the hyperbola. Therefore, the point p satisfies the equation of the hyperbola. Put x as x1 and y as y1. We get a square m square minus b square is equal to c. This is the required condition of the tangency. म्हणजे दिलेली लाइन हे हायपरबोलाचे tangent आहे की नाही हे करण्यासाठी it is sufficient to show that c square is a square m square minus b square. This is called condition of tangency. And point of contact is x1 and y1. That is, point of contact is minus a square m upon c and minus b square upon c. Now, for the conic, every conic section, we have circle eccentricity, equation of curve x square plus y square is equal to a square है. त्याचे tangent equation x1 plus y1 is equal to a square. Condition for tangency c square is equal to a square m square plus a square. आणि त्याचे डायरेक्ट सर्कलचे इक्वेशन x square plus y square is 2a square. मग पॅराबोलासाठी इसेंट्रिसिटी 1 असते. इक्वेशन आहे y square स्टँडर्ड पॅराबोलाचं y square is equal to 4ax. त्याचे टेंजेंसी इक्वेशन y1 is equal to 2ax plus x1. Condition of tangency of the parabola is c is equal to a upon m, and directed circle equation of the directed circle of the parabola is x plus a is equal to 0. Now for the ellipse, eccentricity is less than 1. Equation of the ellipse is x square upon a square plus y square upon b square is equal to 1 where a is greater than b. That's a tangent equation x1 upon a square plus y1 upon b square is equal to 1. And condition for tangency of the ellipse is c square is equal to a square m square plus b square. And equation of the directrix circle is x square plus y square is equal to a square plus b square. Now for hyperbola, eccentricity is greater than 1. And equation of the curve is x square upon a square minus y square upon b square is 1. Equation of the tangent at a point x1 upon a square minus y1 upon b square is equal to 1. And condition for the tangency is c square is equal to a square m square minus b square. And the equation of the directress circle is x square plus y square is equal to a square minus b square. Now, upon pilot tangent at a point px1 y1. Now tangent from the point to the hyperbola. Tangent from a point to the hyperbola. Two tangents can be drawn to the hyperbola from any point outside the hyperbola in its plane. Let px1 y1 be any point in the plane of the hyperbola. The equation of the tangent to the hyperbola is y is equal to mx plus or minus square root a square m square minus b square. आता हे कशावरून आलेलं आहे की आपल्याला इक्वेशन ऑफ टॅन्जंट आपण पाठीमागच्या स्लाइड मध्ये बघितलं y is equal to mx plus c. ती c ची व्हॅल्यू प्लस और मायनस a square m square minus b square येते. c square ची व्हॅल्यू टेकिंग स्क्वेअर रूट c is equal to a square m square minus b square. जर ही टॅन्जेंट x1 y1 या पॉइंट मधून पास होत असेल तर त्या पॉइंटने इक्वेशन सॅटिस्फाय होणार. म्हणजे x is equal to x1 आणि y is equal to y1 या इक्वेशन मध्ये पुट केलं की आपल्याला हे इक्वेशन मिळेल y1 minus mx1 is equal to plus or minus square root a square m square minus b square. Squaring on both sides, simplifying the quadratic equation, we have m square x1 square minus a square m square, that is minus 2x1 y1 m plus y1 square plus b square, that is x1 square minus a square m square minus 2x1 y1 m plus y1 square plus b square. Simplifying this, we get this equation which is quadratic equation in m. These have two roots, say m1 and m2. These are the slope of the two tangents. Therefore, two tangents can be drawn to the hyperbola from a given point in its plane. Sum of roots is, we know this is quadratic equation in m. Therefore, sum of roots is minus 2h upon b, that is 2x1 y1 upon x1 square minus a square, and product of roots is m1 m2 is y1 square plus b square divided by x1 square minus a square. Now, locus of point of intersection of perpendicular tangents. जर एखाद्या पॉइंट मधून हायपरबोलासाठी कमीत कमी दोन टॅन्जंट आपण काढू शकतो. जर त्या दोन टॅन्जंट एकमेकाला परपेंडिक्युलर असतील, म्हणजेच if the tangent on point P are mutually perpendicular, then we have product of slope is -1, that is y1 square plus b square divided by x1 square minus a square is -1. From this we get x1 square plus y1 square is equal to a square minus b square, which is the equation of the standard circle with center at origin and radius a square minus b square. म्हणजे हे जे सर्कलचं इक्वेशन, हे कशाचं इक्वेशन आहे की डायरेक्टेड सर्कल ऑफ दी हायपरबोला. डायरेक्टेड सर्कल म्हणजे काय, जर त्या हायपरबोलाच्या दोन टॅन्जेंट्स असतील तर त्या दोन टॅन्जेंट एकमेकाला परपेंडिक्युलर असतील अशा पॉइंटचा लोकस म्हणजे आपण त्याला डायरेक्टेड सर्कल म्हणतो. आणि ते डायरेक्टेड सर्कल ऑफ दी हायपरबोला इज x1 स्क्वेअर प्लस y1 स्क्वेअर इज इक्वल टू a स्क्वेअर मायनस b स्क्वेअर. पाठीमागच्या टेबल मध्ये आपण हे इक्वेशन्स पाहिलेले आहेत. तर या पद्धतीने आपल्याला हायपरबोला हा कन्सेप्ट, हा नेचर ऑफ कोनिक आपण स्टडी केलेला आहे. याच्यामध्ये एक्झाम्पल्स इम्पॉर्टंट आहे, त्याचे फॉर्म्युले टॅब्युलर फॉर्म मध्ये दिलेले त्याचे इक्वेशन्स हे इम्पॉर्टंट आहे. अशा पद्धतीने आपण हा टॉपिक कंप्लीट केलेला आहे. थँक्यू.